Hello and welcome to the More Polynomial Rational Functions video. In this video, we're just going to be talking more about polynomial rational functions. There's no new features I'm going to be showing you. However, I will be doing one full problem altogether, so not separating it out into features and the graph. So for this, if you take a look at the blank notes, we're going to be going just over problem number 4 together. And this one, while no new features, I think has an interesting piece to it, so I wanted to make sure we went over this. So this is f of x is equal to negative 2x squared plus 2x divided by x squared plus x. So I look at this and I go, okay, something needs to be factored out. So if I take a look at my numerator, I see that we're going to have, if I just want this to be x, I can pull out a negative 2 as well as an x in the numerator, leaving us with negative 2x times x minus 1 over, in my denominator we have x squared and an x, so I can factor out an x there, over x times x plus 1. Now I see that I have an x in my numerator and an x in my denominator, so I'm going to cancel those out. We're going to be left with negative 2 times x minus 1 over x plus 1. This is the equation that we will be using from now on when we check everything out. But I go back and I ask myself, well, what about this x that we canceled out? Remember, if you have a factor in your numerator and your denominator that you canceled out, that then becomes a whole. So even though it's just an x by itself, it's still a factor. So if we take a look at this whole, first thing we need to do is we need to find the x value of that whole by taking that factor that we canceled out and setting it equal to 0. So in this case, we'll take our factor x, set that equal to 0, and we have our x value. X is equal to 0. Love it. Done. Next thing we need to do is we need to go through and find the y value of our whole. So I'm going to take our x value of 0, and I'm going to plug it in to our new simplified version. So this is going to be negative 2 times 0 minus 1 over 0 plus 1. So we negative 2 times negative 1 over 1. Negative 2 times negative 1 is, 2 over 1, which just ends up being 2. So now that we have the x value and the y value, my very last step is to write this as an ordered pair of 0, 2. So this is where I'm going to have a whole or a physical open point in my graph. Next, we're going to go through look at some of our other features. So if we take a look at our vertical asymptote, remember we find that by setting our denominator equal to 0. In this case, our denominator is now just x plus 1. And we end up with x is equal to negative 1. So we have a vertical asymptote at x is equal to negative 1. And now if we wanted to write in our domain, we have two places or restrictions. We are going to have a break at negative 1 because of our vertical asymptote. And we're going to have a break at 0 because that is the x value of our whole. So our domain goes from negative infinity to negative 1, negative 1 to 0. So that break at negative 1 is because of the vertical asymptote. And then we go from negative 1 to 0 and 0 to infinity with that break in 0 because of the whole. Next thing we're going to do, now that we have our vertical asymptote in our domain, let's take a look at our horizontal asymptote. Now in the polynomial form for our horizontal asymptote, we're going to take a look at the degree of the numerator and the degree of the denominator. So in this case, I see the degree of the numerator is 1 and the degree of the denominator is 1. So since the degree of the numerator and the degree of the denominator are the same, we're going to look at the two numbers out in front. So in this case here, that looks to be negative 2 over, this is over, that's still a highlighter. This is over 1. So when I find my horizontal asymptote, we'll say that y is equal to negative 2 over 1, which is just negative 2. And again, we have that because the degree of our numerator was equal to the degree of our denominator. So now that we have our horizontal asymptote, let's go for that range. And again, there's going to be two restrictions or two discontinuities for the range. there's going to be the y value of the whole as well as our horizontal asymptote. So our range is going to go from negative infinity to -2, and from -2 to +2, and from 2 to infinity, with that break in -2 being for the horizontal asymptote, and the break in +2 being for the y value of the whole. So we have our whole, vertical asymptote, horizontal asymptote, domain, and range, and we have two features left to go, our x and our y intercept. So just a reminder, for the x-intercept, you can set the whole equation equal to 0. However, in polynomial form, you can also have a shortcut by just setting the numerator equal to 0. So for the x-intercept, I'm going to say 0 is equal to -2, oops, pardon me, that's not +1, that should be -1. Now I'm going to take this -2 and distribute it inside here. So we'll have 0 is equal to -2x plus 2. Then to get x by itself, I'm going to subtract 2 on both sides. Get -2 is equal to -2x. And then divide both sides by -2 and get x is equal to 1. So don't stop here. We still need to write this as a point. So our x-intercept is at 1, 0. So that is our x-intercept. Next, for our y-intercept, actually, I think, you know what, I'm going to write this over here. Thank you for your patience. So for our y-intercept, what we do is we plug in 0 for x and we solve, except I remember already doing that, right? When we were up here with our whole, we've already plugged in 0 for x and solve. We know that we get 0 too. We've already done that work. But since we have a whole here, that's an open point, it means we're not going to have a closed point on our y-axis, because that's where we're going to have an open point. So for the y-intercept, I'm just going to say that there's no y-intercept. And the reason for that is that we have a whole when x is equal to 0. So normally the way that we would find our y-intercept is plugging in 0 for x, but we've already done that. So sometimes you'll have an intercept, sometimes you won't, and that's okay. But these are all of our features. Now let's get to making our table. So let's see, when we make our table, we're going to leave 1, 2, 3 blank spaces right in our vertical asymptote, which in this case is -1. Right asymptote to remind myself. And then 3 more blank spaces. And the reason that we do this is so that we have 3 points on either side of our asymptotes to make sure we can see everything fully. From our vertical asymptote of -1, we're going to count backwards half a step, and then we'll go back full steps. So going backwards half a step is going to be at -1.5, and then going backwards to whole numbers, we'll have -2 and -3. And then moving forward from -1 half a step, we'll have -0.5, or -1/2. And then continuing going forward, we'll have 0 and 1. Now from here, if we have any features that are not already listed in the table, we would add those in. But I see that we already have our x-intercept at 0, 1, and we also have our whole, or probably at 1, 0, we already have our whole at 0, 2. And I'm just going to write a note to myself that this is my whole, and I'm even going to highlight that point just so I remember that when I'm graphing, that I'm going to want to write that differently than my other points. Now, to go through and fill in the rest of the table, you can do this by hand, you can use your calculator. I'm just going to let you know that when you plug in -3, you get -4 as your y value. When you plug in -2, you get 6 as your y value. When you plug in -1.5, you get -10 as your y value. And when you plug in -0.5, you get 6 as your y value. So this is our whole table. It has all the features that we need. I'm now going to pause this video so I can bring up a graph. So now that we have a graph, first thing I'm going to do is I'm going to mark in those asymptotes. Again, we have a vertical asymptote when x is equal to -1. So it's going to come all the way down here. And we're going to have a horizontal asymptote when y is equal to -2. Remember to mark in your asymptotes with a dashed line. Now, you can either go through your table, or you can just mark in your important features first. So first important feature, we have an x-intercept at 1, 0. So that's going to be right here. We also have a hole at 0, 2. So remember to draw that as an actual open point. Since those are in the same quadrant, I might just move backwards up my table and use this last point of negative 0.56 to mark in my right side. And that'll be right here. Just a reminder, when you're graphing it, you don't want to graph through the hole. So we're going to go from the hole up this way and from the hole down this way. And we can have our, oops, there we go. We can have our proper graph. From here, let's do the left side. We have negative 1.5, negative 10, which will be down here, negative 2, negative 6. We'll have negative 3, negative 4. So again, don't just connect your points like this. Make sure you go all the way through the other side. So there you are. This is what one full problem looks like. Let me know if you have any questions. Please remember to go back and look at the transformational form that we went over on Monday as well. That will be on the test. But this should be the last of the graphing. Let me know if you have any questions. I look forward to seeing you tomorrow.